Bismillahirrahmanirrahim. Assalamu alaikum class. Welcome to the first part of our lecture 19. In the previous lecture, we have studied cumulative distribution function of continuous random variable and the expected value and variance of continuous random variable. Cumulative distribution function of a continuous random variable is represented by capital F of x and it is equal to probability x is less than equal to small x, and it is calculated by integrating probability density function with respect to x from lowest limit of variable to the x, and the expected value of continuous random variable is equal to x into f of x dx, and we integrate it on the complete limits of the distribution, and the variance of x when x is a continuous, it is equal to expected value of x square minus expected value of x whole square. And how we will calculate expected value of x square? This is equal to integration of x square into f of x dx, and we integrate it on complete limits of our distribution. Okay. Today we will study binomial distribution. Introduction. Binomial distribution was discovered by James Bernoulli in 1738. It is a discrete probability distribution. A discrete probability distribution applicable to the scenarios where the set of possible outcomes is discrete, such as a coin toss or a roll of dice, can be encoded by the discrete list of probabilities of the outcomes known as probability mass function. Bernoulli binomial distribution is named after Bernoulli, who first invented the Bernoulli Trials, and then we lead it to the binomial distribution. Binomial distribution is the first discrete distribution we are going to study. We have studied discrete random variable, and what was that? We studied that a random variable, a real valued function defined on the sample space of random experiment, is a random variable, and when the random variable assume only the whole numbers integer values, then it is a discrete random variable. So the probability distribution of discrete random variable is discrete probability distribution. Now we have some assumptions, some scenarios. When it fulfilled, we said that that experiment is actually the binomial experiment. We will study. First, we will see what is Bernoulli Trials. James Bernoulli analyzed the idea of repeated independent trials for discrete random variables that had two possible outcomes, success or failure. What James Bernoulli first do? He analyzed the idea of repeated independent trials. What is trials? We have studied that number of times an experiment repeated is known as the number of trials an experiment is done. एक एक्सपेरिमेंट को हम कितनी दफा रिपीट करते हैं, that is the trials. For example, if we are tossing a coin, what is experiment? Tossing a coin is an experiment. What is trial? If we toss coin 3 times, how many times we have repeat our experiment? 3 times. This is the trial. There are 3 trials. Okay. Repeated independent trials. Independent trials होंगे हमारे पास. Trials are not dependent on any other. That had 2 possible outcomes. And there are only 2 possible outcomes. There are only 2 classifications in which we can classify our outcome, success or failure. What is success and what is failure? Anything in which our interest is lies, that is success. And except that, everything else is a failure. For example, if we roll a die and we are interested in the occurrence of 5, then the occurrence of 5 is the success, while if any other number occur, that is a failure. Okay? In this notation, he wrote that the probability of success is denoted by P and the probability of failure is denoted by Q. When the James Bernoulli done his analysis, he used 2 notations, P and Q, where Q is equal to 1 minus P. P is used to represent the probability of success, and remember this is small p. And the small q is used to represent the probability of failure. Binomial distribution. The binomial distribution is just an independent individual Bernoulli trials added up. The word binomial literally means 2 numbers. A binomial distribution for a random variable x known as binomial variate is one in which there are only 2 possible outcomes, success and failure, for a finite number of trials. What is binomial distribution? When the Bernoulli trials, which we have studied in the last slide, when the Bernoulli trials added up and more than one and independent Bernoulli trials added up, it becomes the binomial distribution. Note that, however, we define success and failure that 2 events must be mutually exclusive and complementary. That is, they cannot occur at the same time, mutually exclusive, and the sum of their probabilities is 100%, complementary. I have told you that how we define success and failure. The events in which our interest lies is classified as success, and anything else occur is the failure. Now, when we define success and failure, we must remember that success and failure should be mutually exclusive and complementary. They will always be mutually exclusive and complementary. As by the name, we can see success and failure cannot occur at the same time. It is not possible that both the success and failure occur at the same time. And we also know that if success occurs, failure does not. They are complementary. Okay. Assumptions for binomial distribution. What are the assumptions which will fulfilled, and we said that the given experiment is actually follow the binomial distribution. The first assumption is, for each trial there are only two possible outcomes, success and the failure. The second assumption is, number of trials are fixed. Number of trials are represented by small n. And we say that number of trials are fixed in the experiment. The trials are independent. What does that mean? It means the outcome of trial is not affected by the outcome of any other trial. So there are two assumptions on the trials. First one was trials are fixed, and the other is trials are independent. Trials does not depend on any other thing. The outcomes of trial is not affected by the outcomes of any other trial. And the last assumption of binomial distribution is, probability of success, which is denoted by small p, is constant, or we say is same from trial to trial. That the probability of success will not change from one trial to another trial. For example, as we have said, we roll a die and our interest lies in occurrence of 5. Now, occurrence of 5 is success. Now, what is the probability of occurrence of 5? The probability of occurrence of 5 is 1 by 6. हमारे पास 5 की फेवर में कितने आउटकम्स हैं? 1 और टोटल कितने? 6. 1 by 6. If this is probability of success, probability of occurrence of 5. If we repeat our experiment in second trial, what is the probability of occurrence of 5? It will again be 1 by 6. So, probability of success same from trial to trial. Probability mass function of binomial distribution. When we get to know that these assumptions, these 4 assumptions are fulfilled by some experiment, then we say that this experiment actually follows binomial distribution. Now, what we will do, if some experiment follows binomial distribution, then we can find the probability of any of x by using probability mass function of binomial distribution, which is predefined. In binomial experiment, the probability of exactly x successes in n trials is probability of x is equal to ncx. This is combination ncx small p raised to power x q raised to power n minus x. X is equal to 0, 1, 2 and so on n. Now, in this probability mass function, what is x? Small x. Capital X represents the random variable and small x is the value of capital X. It also represents the number of successes. Okay. हम random variable किसको define करते हैं? The thing in which our interest lies. Success को हम random variable define करते हैं. So small x is the number of successes. What is small n? Small n is the number of trials. What is small p? Small p represents the probability of success. What is small q? Small q represents the probability of failure. And there are two parameters of binomial distribution, n and p. If these two parameters are known, we can find the whole distribution function, whole probability distribution. How? We know that probability of success and failure are complementary. If P is known, we can find Q. What is the value of Q? 1 minus P. And when N is known, we know what is the range of X. We will put the values of X, any of the value, and we will get the required probability. This is all for this part. Thank you.